Good morning, third grade. Our targets for today are: I can identify the parts and whole in a put-together story problem, and I can solve put-together story problems using a bar diagram. You know that in a put-together problem, there are two amounts. There is no action. The two amounts are put together to make a new amount, the total. In a put-together problem, the two amounts are both parts. The amount that gets larger, the result amount at the end, is the whole. We represent put-together problems using a bar diagram. Sometimes you add to solve a put-together problem. If the whole is unknown, you add, because part plus part equals whole. Sometimes to solve a put-together problem, you subtract. If a part is missing, you subtract, because whole minus part equals part. Put-together problems are different than get-more problems because put-together problems have no action. Instead, the two amounts are put together or combined. Some key words you might see that let you know a problem is a put-together problem would be the words combine, put together, in all together, and total. Every put-together problem has an amount, the first amount that a person or group has, another amount, the second amount that a person or group has, and a result amount, which is the whole. It's the amount after both parts are put together or combined. There are some words that can help you know if a piece of information is a result amount or total amount, the whole. When you see the word total, that tells you that the amount is the result amount or the whole. The words in all together, now, and end up with can also help you know that a piece of information is the result amount or the whole in a put-together problem. You know that we use the problem-solving process every time we solve a story problem. First, we read and understand, finding the information we know and what the question is asking us to find out. Then we plan, we determine the problem type, and organize the information. When we solve put-together problems, we organize the information into a bar diagram. Then we solve the problem. We choose the operation that will let us find the missing piece of information, and we solve. Finally, we look back and check. We look at our work and we ask ourselves, is this answer reasonable? Today, we're going to focus on two parts of the problem-solving process. We're going to focus on reading and understanding put-together problems and also on how we would solve them. Today, third grade, you will see put-together problems that have a missing whole or result amount, and you will also see put-together problems where one of the amounts is missing or a part. So today, you'll have to determine what information is missing, a whole or a part, in the story problem. So today, you'll have to determine what information is missing, the whole or a part. Again, we're going to today focus on reading and understanding and solving the problems. Right now, we're going to focus on reading and understanding put-together problems. Here is a put-together problem. On Saturday, Zoe and Maddie watched a movie. Zoe brought 24 M&Ms to share, and Maddie brought 36 Skittles to share. How much candy do they have total? We're going to start by reading and understanding this problem. We need to find the information that the story problem gives us. One piece of information the story problem gives us is that Zoe brought 24 M&Ms. Can you find the other piece of information the story problem gives us? Yes, the story problem also tells us that Maddie brought 36 Skittles to share. The question that the story problem is asking is, how much candy do they have total? Now we need to determine which pieces of information are the amounts and which piece of information is the result or whole. Well, let's read the problem again and think. What would be the parts or the amounts, and what would be the whole, the result, the total? On Saturday, Zoe and Maddie watched a movie. Zoe brought 24 M&Ms to share, and Maddie brought 36 Skittles to share. How much candy do they have total? When I look at that first piece of information, I see that Zoe brought M&Ms. I know that this is a part because Zoe brought M&Ms and Maddie brought Skittles. Zoe brought some candy and Maddie brought other candy. They both brought candy to share. So both Zoe's 24 M&Ms and Maddie's 36 Skittles are amounts or parts. The question asks how much candy do they have total? Both the M&Ms and the Skittles are kinds of candy. So the candy is going to be the total. I also know that this is the total because it says the word total, how much do they have total, and even the word they is a clue. Maddie and Zoe together are they, so this is asking me about the amount they have after they put their candy together. This is asking me about the result amount, or the whole. We're going to look at another problem and carefully read and understand it. Remember, right now we're focusing on that first step of the problem-solving process, reading and understanding put together problems. Here is another story problem for us to read and understand. Remember, we're going to read it, find the information, find the question, and then determine which pieces of information are the amounts or parts, and which piece of information is the result or whole. Mrs. Logan picked 24 flowers from her garden. She put 14 flowers in a vase on her table and the rest in a vase on her shelf. How many flowers did she put in the vase on her shelf? What are the pieces of information in this story problem? One of the pieces of information is that Mrs. Logan picked 24 flowers. What is the other piece of information? Yes, the other piece of information in this problem is that she put 14 flowers in a vase on her table. What is the question in this story problem? Oh yes, the question this problem is asking is, how many flowers did she put in the vase on the shelf? Let's read this problem again and really think about what pieces of information are the amounts and what information is the result or total amount. Mrs. Logan picked 24 flowers from her garden. She put 14 flowers in a vase on her table and the rest in a vase on her shelf. How many flowers did she put in the vase on her shelf? Well, look at the first piece of information. She picked 24 flowers. Let's think about this together. We know she picked 24 flowers, and then we know that she put 14 of those flowers in a vase on her table, and the rest of them she put on her shelf. Think about this piece of information, picked 24 flowers. Is that going to be one of the amounts or the whole? Really think carefully. She picked 24 flowers. She put 14 of those flowers into a vase on her table and the rest in a vase on her shelf. Oh, what do you think? Is this one of the amounts or is this the whole? You're right. Picked 24 flowers is the whole because she picked all of the flowers. 24 is all of the flowers. And then she put some on her table and some in the vase on her table and some in the vase on her shelf. So this 24 flowers is the whole. It's all of the flowers she picked. I know it's unusual in a put-together problem for us to see the whole at the beginning of the problem, but it can happen. The wholes and parts can be anywhere in the problem. We have to read carefully to determine what is the whole and what is the part. Now, look at the next piece of information, 14 flowers in a vase on her table. Do you see any keywords that help you know that this is an amount? I noticed that it says vase on her table. This helps me know that this is an amount. She put some of the flowers in a vase on her table. She put the rest of them in a vase somewhere else. The fact that this is a vase on her table makes it different from the other vase. It makes it different from where she put the other flowers. So this is one of the amounts. Now look at the question. How many flowers did you put in the vase on her shelf? Do you see any key words that help you know that this is also an amount? I absolutely agree. The words vase on her shelf help me know that this is also an amount. We know that some of the flowers went to a vase on her table and the rest of them are on this vase on the shelf. She has 24 flowers total. Some are in that vase on the table and some are in the vase on the shelf. The flowers in the vase on her table and the flowers in the vase on her shelf are the two parts. Now I want us to think about parts and wholes. You know that when the unknown number in a story problem is the whole, you have to add because part plus part equals whole. You also know that when the unknown number in a story problem is a part, you subtract because whole minus part equals part. One more time. If the unknown number is the whole, you add because part plus part equals whole. When the unknown number is a part, you subtract because whole minus part equals part. We're going to use that information to solve a couple of bar diagrams. Here you can see I have a bar diagram with some numbers in it. I have 418 as a part and 109 as a part. Think to yourself, what is missing in this bar diagram? Is the unknown information a part or the whole? You're right. The unknown information is clearly the whole because there is n in the whole, representing that that is unknown. When we have an unknown whole, will we add or subtract to find it? You're right. When we do not know the whole, we add because part plus part equals whole. Think, what equation will we write to solve this problem? You're correct. We will write the equation 418 plus 109 equals n. On a piece of scratch paper, write 418 plus 109 vertically and add it carefully, making sure to regroup if you need to. Then you can tell me what n equals. You are so right. N equals 527. We added our two parts together, 418 plus 109, and it equaled our whole, 527. Let's look at another bar diagram together. Here you can see in this bar diagram that my whole is 753 and one of the parts is 311. I want you to think in your brain, what piece of information is missing? Is the whole the unknown or is one of the parts the unknown? Yes, in this bar diagram, we do not know one of the parts. One of the parts is unknown. When a part is unknown, do we add or subtract to find the unknown part? Yes. When a part is unknown, we subtract because whole minus part equals part. Think, what equation will we write to solve this problem and find what n equals? We would write the equation 753 minus 311 equals n because whole minus part equals part. On a piece of scratch paper, write 753 minus 311 vertically and solve it. Then you can tell me what n equals. Yes, when you subtract 753 minus 311, it equals 422. So, yes. When you subtract 753 minus 311, it equals 442. So n equals 442. We are now going to focus on step 3 of our problem-solving process, solving the story problem, choosing the correct operation to find the unknown information, and then actually solving. Let's go ahead and look at those same two story problems. We'll start with the story problem about Zoe and Maddie. Just to remind ourselves, let's reread the story problem one time. On Saturday, Zoe and Maddie watched a movie. Zoe brought 24 M&Ms to share, and Maddie brought 36 Skittles to share. How much candy do they have total? You can see that I've already filled out the bar diagram. Since we were so careful and labeled all of the parts and the whole in the story problem, I was able to fill it out for us. Take a look at that bar diagram. What is the unknown, a part or a whole? Yes, in this story problem, the unknown information is the whole. Now I want you to think, what operation will help us? Will we add or subtract to solve this problem? Yes, the operation that will help us is addition, because part plus part equals whole. When a whole is unknown, we add, because part plus part equals whole. Finally, what equation would we write to solve this problem? Yes, we would write the equation 24 plus 36 equals n, because part plus part equals whole. I would like you on your piece of scratch paper to actually solve the problem 24 plus 36 equals n. What does n equal? You're absolutely right. In this problem, 24 plus 36 equals n equals 60. So we now know that the girls have 60 pieces of candy total to share. Now let's go ahead and look at that problem about Mrs. Logan and her flowers. Let's reread it to ourselves to help keep it fresh in our minds. Mrs. Logan picked 24 flowers from her garden. She put 14 flowers in a vase on her table and the rest in a vase on her shelf. How many flowers did she put in the vase on the shelf? As you can see, I've already filled out the bar diagram for us. Since we labeled the whole and parts in the story problem, I was able to fill it out for us. Look at the bar diagram, and I want you to think, what is the unknown in this problem, a part or the whole? In this problem, the unknown information is a part. Now I want you to think to yourself, what operation will help us? Will we use addition or subtraction to solve this problem? Think about the unknown. That will help you decide. To solve this operation, we will use subtraction. Because the piece of information that is unknown is a part, we will subtract. Whole minus part equals part. I would like you to think, what is the equation we would actually write to solve this problem? To solve this problem, we would write the equation 24 To solve this problem, we would write the equation 24 minus 14 equals n. On your piece of scratch paper, go ahead and actually solve 24 minus 14 by subtracting vertically. So you can tell me what n equals. In this problem, 24 minus 14 equals n. N equals 10. So you now know that Mrs. Logan put 10 flowers in the vase on the shelf. Thank you for solving put together story problems with me today, third grade. Have a wonderful day.